Hi, I'm Marcher Claros with my partner Janessa Makaalin. And for today's topic, we will be discussing about the special instruments to measure the upper air data, the weather satellite data, and for modern tools for the weather analysis and what causes rainfall. And you should expected to know the special instruments to measure the upper air data, the weather satellite data, and for modern tools for weather analysis and what causes rainfall. And you should learn about the different types of the widely instrument to obtain the upper air data. So this equipment described to use the measure weather conditions at the near the Earth's surface from a distance of no more than 16 meters from the observer's position. So knowing that the characteristics of the atmosphere above is important when forecasting weather the upper air. So the weather forecaster has know the humidity, temperature, pressure, wind speed, and wind direction at various levels of the atmosphere in order to have a better picture of the current weather conditions. So from the ground up, the majority of the significant weather changes and their consequences in order to have a daily lives occur at the level above what we can see or feel near the Earth's surface. Some of the widely used instruments to obtain the upper air data are the following. The first one is piebald theodolite known as the pilot balloon theodolite. So these balloons elevation and horizontal azimuth angles are recorded and that data is plotted on a plotting board at the end of a flight, which can last for more than an hour. Trigonometric methods are used to calculate the wind speed and direction at different heights. During daylight hours, meteorologists use a sailing balloon, also known as a pilot balloon or piebald, to determine the height of the cloud base above ground level. A theodolite was used to track the balloon in order to determine the speed and directions of winds aloft in the past, and still is in the some cases today. You know that piebalds and theodolites have a long history in meteorology. For over 125 years, they have been used to monitor the upper level winds. They are now only used in a few specialized but often critical applications, usually in remote locations where Rainfall data is not available. The second one is radiosonde. The use of a radiosonde is a more advanced means of studying the upper atmosphere. A radiosonde is an electronic instrument that measures pressure, humidity, wind speed, and directions. It is also tied to meteorological balloons and rises through the atmosphere. It takes required measurements as radio signals, which are not transferred to a weather station ground and receivers where they are decoded and assessed. The next one is the wind-finding radar. The use of wind-finding radar, also known as a Doppler radar, it is another means of measuring the upper air data. It uses radar echoes to determine the speed and the direction of the winds aloft. The balloons has a radar target connected to it, which is being tracked by terrestrial radar. The receiver determines the viewing and interval time of the echoes. In today's aviation industry, radar technology has become critical. Radar is used for air traffic control and navigation, in particular in the aviation industry. Weather radars are being used to improve aircraft safety and efficiently across the board. The fourth one is weather surveillance radar. At a distance of up to 500 kilometers, the weather surveillance radar detects and monitors typhoons and cloud masses. The revolving antenna disc for this radar should be installed on the top of the building, away from the physical obstructions. The transmitter's radio energy is focused by the antenna and shot outward in a narrow beam through the atmosphere. Whether or not the cloud mass is part of a typhoon, it reflects a small amount of energy back to the antenna on the radar scope. The reflected energy is amplified and visually displayed. And the last one is satellite imagery. Those images of the Earth gathered by the imaging satellites operated by the governments and businesses across the world are known as a satellite imagery. Satellite photos how the human footprints is changing around the world, including fast expanding cities, urban sprawl, and informal settlements. Satellites imagery is increasingly being used to measure and identify the track human activity. Satellite images are one of the meteorologist's most powerful and important tools. They are essentially the sky's eyes. These visualizations reassures that the forecasters about the behavior of the atmosphere because they show how events are happening in the straightforward, simple, and an accurate manner.
So we have here the modern tools for weather analysis. The first one is the polar obtaining satellites, in which it is passed over the north and south poles as they orbit the Earth. A polar orbit is also used by Iridium satellite constellation to provide telecommunication services. And the other one is Geostationary Meteorological Satellite, or the GMS. A spin-stabilized geostationary meteorological satellite is launched into geosynchronous orbit over the equator. The height is approximately 35,800 kilometers above the sea level. The observation of the Earth and cloud imagery is the first mission of the GMS. Well, we also have here the visible and infrared spin scatteradiometer. It is used to measure temperature on both the Earth's surface and cloud tops. The GMS provides users with real-time digital clouds images. Data can be processed not only by a high-grade computer system, but also by a regular personal computer system that is due to the help of medium-scale data utilization station. So the other thing that we're going to discuss here is what causes rainfall. So rain is made up of water droplets that descend from clouds. Condensation of water vapor causes clouds to develop in a free atmosphere. To form raindrops, cloud droplets coalesce or merge together. For the cloud or droplets to fall, condensation nuclei must exist, which could be combustion products, dust particles, or salt particles. Vertical air currents in the clouds will accelerate the formation of these coalesced clouds droplets, resulting in rain-bearing clouds. This must be large-scale vertical air currents that move water vapor from the Earth's surface upward into the atmosphere to keep cloud formation going.